This is lesson 1.2, the real numbers, in the second lesson of chapter 1 in elementary algebra. And one of the things that you've done all of your young lives is work with number lines. And that does not go away just because you're a big kid. Number lines are used for everything because it graphically gives us an idea of what's happening with numbers. So I'm going to do each one of these as 5. I got room here. Okay, notice everything to the left of 0 is in the negative direction, and everything to the right of 0 is in the positive direction. Very important to know that the negative sign represents a direction that you're going on the number line, and that's it. So don't get too freaked out about what all that means. And this is called a real number line, which means all real numbers are numbers that can actually be placed on a number line. Some numbers cannot be placed on a number line, and we call those complex numbers, or actually we call those imaginary numbers. You can't put imaginary numbers on a number line. Makes sense, right? A number that doesn't exist, you can't make it exist. So anyway, when we are going through these different definitions, I would put these in your notes. Definitions 1 and 2 are the first and second ones that have to do with coordinates and real numbers. You can write those down. Those make sense. Comparison symbols you've already used. Subsets of real numbers means that if we have real numbers, and I use an R that looks like that to represent real numbers. This is just kind of a double line there that's capitalized. It shows real numbers. And subsets of real numbers means that within the real numbers there are other numbers. So for instance, let's see, how can I explain this? You get a bag of fries at McDonald's. You have fries. Well, inside that bag you have individual fries. They are subsets of that set of fries. It's the same thing with real numbers. You have all these numbers, but maybe you're only interested in the numbers 1, 2, 3, etc. all the way into infinity. You don't care about negative numbers, you don't care about zeros, you don't care about fractions. Those are called counting numbers. If you have numbers that are whole numbers, they're the same as the counting numbers, only we're adding 0 to them, to that list. So all the positive numbers that are not fractions, and then you're going to add 0 to that, and you've got whole numbers. Integers are all of those numbers that we have there, plus all the negative numbers. And again, these are like counting numbers backwards. No fractions, just all the numbers that you normally would count. And then we get to what are called rational numbers. Rational numbers are numbers that can be written as a fraction. So 1/5 is a rational number. 6 over 2 reduces to 3, but it can be written as a fraction. So even if it's 6 is the same as 6 over 1. It can be written as a fraction. And so those are rational numbers. Irrational numbers are numbers that cannot be written as a fraction because they never end. So like pi. Pi is 3.1415, and it goes on and on and on forever. It never ends. So this is an irrational number because you can't write that as a fraction. You can write, like if you just wanted to write this part of it right there, it would be 3.1415 over 10,000. So it can be written like that, but what about all these other numbers here that go into infinity? You can't write those over a number. So pi is called an irrational number. So real numbers, which we represented like this, are pretty much all the numbers you're going to be working with right now. We might get into some imaginary numbers, which sound like, oh my gosh, are you freaking kidding me? Imaginary numbers, they're not that bad. I think you'll get to the point where you're like, oh, nothing, no problems, I can do this. These are pretty easy. At least that's the way all my other students have been, that they're pretty easy. Okay, so let's keep jumping down here to example 5. And what they've got is they've got a fraction, 18 over 30, and they're asking you to reduce that. What I normally suggest doing, because when you've got bigger numbers, it makes sense to do this, is we're going to write the product of primes, which means we're going to take the 18 and write all the numbers that are prime numbers that we can multiply to get 18. So that's the product of primes. If we take the product, if we multiply all those, we'll get 18. And they're all prime numbers. No number goes into 2, 3, except 1 in itself, so that makes it prime. I'm going to do the same thing with 30. 3 times 2 is 6 times 5. Then I can cancel. I can cancel this 2 with this 2, this 3 with this 3, and 18 over 30 reduces to 3/5. So there is the reduction, or reducing 18/30ths. Now a lot of you will look at this and go, oh, 6 goes into 18 3 times, 6 goes into 35 times, done. That's fine. But when I give you a number like 368 over 1,327 and ask you to reduce it, you're not going to do it as easily. So if you can write the product of primes of this, product of primes of that, cancel what's common in the numerator and denominator, you'll get your reduced fraction. Okay, so let's look at absolute values and opposites for a minute. Just to give you the idea of what an opposite is, if we have a positive 5, its opposite's negative 5. If I give you negative 1/2, its opposite's 1/2. Okay, so that's all opposites are, is if one's a positive, the other one's a negative. So absolute values, again, it's one of those things that you've probably already done, but since you learned it from another teacher, you'll learn it from me, probably a little bit different. But absolute value is written like this. And those two lines are called absolute value signs. And what we've got, let's put our number line on there. All that absolute value sign means is how far is the number inside from 0. So we go up to 5, and it's 5 away from 0. We look at this one, and it's also 5 away from 0. So all this negative here, remember, means is what direction did we go from 0? Okay, so how far is 5 from 0? 5. How far is negative 5 from 0? 5. So the absolute value of any number is that number made positive, because it's just looking at the distance. So if you are at school and you go to McDonald's and it's 2 miles, you went 2 miles there. Well, when you turn around and come back, you don't go in negative 2 miles just because you're coming back. You still go 2 miles, but you're just going in a different direction. So that's what this symbol here, or lack of symbol, means. That you're going in 2 different directions, but you're going the same distance because the number represents how far you went. So if I have negative 2.3 and I want the absolute value, it's just going to be positive 2.3, and you take the absolute value signs off and you're done. So that's really all there is to absolute values, and that takes care of lesson 1.2 in 8.5 minutes.